Hello and welcome to Mathematics with Mr. Kumalo. Please hit that subscribe button and that notification bell so you get notified when I drop the next video. In this video, I am going to teach you how to complete a factor tree diagram, and I am also going to teach you how to use your factor tree diagram to find the HCF between two or more numbers. Without wasting time, let's take a look. Right, first of all, what do we mean by the HCF? So HCF stands for the highest common factor. And what is a factor? So a factor of a number is a number that can go into a given number without leaving a remainder. A factor of a number is a number that can go into the given number without leaving a remainder. For example, here the given number is 6. So if I were to write the factors of 6, the factors of 6 would be all the numbers that can go or divide the number 6 without leaving a remainder. So 1 can go into 6 without leaving a remainder. 2 can go into 6 without leaving a remainder. 3 and 6 can go into 6 without leaving a remainder. So as you can see, 6 has 1, 2, 3, 4 factors because all these numbers can be divided or can divide 6 without leaving a remainder. So you can see the number 4 and the number 5 are not there. Why? Because the number 4 is not a factor of 6. Because if you were to divide 6 by 4, you would have a remainder of 2. Right? Because 4 can only go into 6 once and you would have a remainder of 2. So 4 and 5 are not factors or factors of 6 because they would leave a remainder. So a factor of a number is a number that can go into any given number without leaving a remainder. Then the next thing we need to look at is our prime numbers. We need to understand what is a prime number and how we can use them in order to complete our factor tree diagram. So what is a prime number? A prime number is a number that only has two factors. We already defined what a factor is, and we said a factor is a number that can go into the given number without leaving a remainder. We saw that 6 has 1, 2, 3, 4 factors, but now a prime number only has 2 factors. In other words, it is the number itself and 1. So for example, 2 only has 2 factors, 1 and the number 2. 3 has only 2 factors, 1 and the number 3. So all our prime numbers only have 2 factors, which is 1 and the number itself. So as you can see on the board, I've written the first 1, 2, 3, 4, 5, 6 prime numbers, but prime numbers just go on and on and on, and any number that has 2 factors, 1 and the number itself, is referred to as our prime numbers. Now, I am going to teach you and show you how you can write your factor tree diagram and how you can use it in order to find the HCF between two or more numbers. Before I show you how you can use your factor tree diagram to find the HCF between two numbers, I want us to look at the first method over here. Now here you can see that we are asked to find the HCF between 6 and 12. So in order to find the HCF between two or more numbers, you go and write the factors of those numbers. So now we want to find the HCF between 6 and 12. So we go ahead and write the factors of 6 and then we write the factors of 12. So HCF stands for the highest or the biggest common factor, or a number that is the biggest that can be found from the factors of 6 and from the factors of 12. And if we look here, the biggest number that is a factor of both 6 and 12 is the number 6. So it is not the number 1, it is not the number 2, and it is not the number 3. Why? Because we are looking for the highest, the biggest number that is the same and that is also a factor of both 6 and 12. So we can see that the HCF of 6 and 12 is going to be 6. Now, how can we use a factor tree diagram in order to find the HCF? Now, the reason why the factor tree diagram is also important is because it will help you, especially when you are dealing with bigger or larger numbers, then you don't have to go and write all the factors, because the bigger the number, the more factors you need to write. So if the number is bigger, it is easier to make use of your stem and leaf diagram or your factor tree diagram, as we are going to be doing right now. Let's take a look at factors or our prime numbers. Right, starting with the number 6. So first of all, you want to ask yourself which two numbers, when you multiply them, will give you 6. So it can be any two numbers, but in this particular case, the number 2 multiplied by the number 3, 2 times 3 is equals to 6. Now we can see that 2 is a prime number, 3 is a prime number. So that means if you were to write 6 as a product of its prime factors, it would be 2 multiplied by 3. Now let's look at the number 12. If we were to write a tree diagram for the number 12, again you ask yourself which two numbers, when you multiply them, would give you the number 12. So usually I try to start with the first prime number, okay? So I ask myself which number multiplied by 2 will give me 12, and if there is no number, I go on to the next number and so on. So I can see here 6 multiplied by 2 will give me 12. 2 is a prime number, so I'm not going to break it, I'm just going to circle it. And now I need to break the number 6, because 6 is not a prime number. So if I break the number 6, I can see that again 2 multiplied by 3 will give me 6. And then I can see the last two numbers are prime numbers, so that means I am done. So if I am to write 12 as a product of its prime factors, it would be 2 multiplied by 3 multiplied by 2. So the order in which you write them doesn't matter, but we can see that 2 multiplied by 3 is 6, 6 multiplied by 2 is 12. So when you write your 12 and 6 as a product of its prime factors, you will notice that all these numbers here are prime numbers. And when you multiply them together, they should give you the number that you are working with. So why did I write them in this particular order, since order doesn't matter? I saw that here I have 2 multiplied by 3, so I just want the 2 underneath the 2, the 3 underneath the 3, just to make it easy for me to circle, but it really doesn't matter. So now how do we go and find the HCF using this method? So you pair the numbers. So I can see these 2 can be paired with these 2, so I'm going to go ahead and circle it. I'm going to pair this 3 over here with this 3 over here, and then I can see that this 2 over here doesn't have a number to be paired with on top. So now that means the HCF of 6 and 12 is equals to, and now I go back to the numbers that I've circled. So it's 2 multiplied by 3, which is equals to 6. So I don't include these numbers. I look at the numbers that I've circled and I just add them once and I multiply them. In the second example, we have the number 100 and the number 220. So first we need to break these numbers up using our prime numbers. So again, looking at my prime numbers, starting with the first one, I ask myself 2 multiplied by which number will give me the number 100. So I can see that 50 multiplied by 2 will give me 100. So I'm going to go ahead and write 2 multiplied by 50 is going to give me 100. I can see that 2 is a prime number, so I leave it. I break up 50 because 50 is not a prime number because it has more than just 2 factors. So now I break up the number 50, and again going back to my prime numbers, I can ask myself which number multiplied by 2 will give me 50. So I can see and I can notice that it would be 2 multiplied by 25 would give me 50. 2 is a prime number, but 25 is not a prime number, so I need to break that up. Which number multiplied by 2 would give me 25? No number. So I check all of them and I can see there is no number multiplied with 3 would give me 25. But then I come to 5 and I realize that 5 multiplied by 5 would give me 25. So since the last 2 numbers are both prime numbers, that is how I know I'm done with my factor tree diagram. So I can go and circle all my prime numbers. And if I had the number 100 as a product of its prime numbers, that would be 2 multiplied by 2 multiplied by 5 multiplied by 5. Now I need to go and write the number 220 using again my prime numbers. Again, starting with the number 2, I ask myself, 2 multiplied by which number would give me 220? So I can see here it's 2 multiplied by the number 110. 2 is a prime number, but 110 is not a prime number. So now I need to break up 110. Starting again, I ask myself, 2 multiplied by which number will give me 110? And I can be able to see that 2 multiplied by the number 55 will give me 110. 2 is a prime number, so I leave it, but 55 is not a prime number, so I need to go and break up the number 55. Again, I ask myself, which two numbers, if I multiply them, would give me 55? And if you were to go to check from here, you would see that you cannot use 2, 3, 5, 7, and you would come to notice that it's actually 11 multiplied by 5, or 5 multiplied by 11. You can use 5, but not 2 and 3. So it would be 11 multiplied by 5. That would give you 55. So both 5 and 11 are prime numbers. Since they are the last two numbers, I know that I'm done with my factor tree diagram and I can go and circle my prime numbers. So now writing 220 as a product of its prime factors, I can say 220 is equals to 2 multiplied by 2 multiplied by 5 multiplied by 11. Now to find the HCF, and remember when you multiply these numbers, they always need to give you the number that you've written here. So if you say 2 multiplied by 2 multiplied by 5 multiplied by 5, it should be able to give you 100. And 2 multiplied by 2 multiplied by 5 multiplied by 11 should give you the number 220. So now to find the HCF, I go and I pair the numbers up. So I'm going to pair the 2 on the bottom with the 2 on top. I can pair these 2 over here with the 2 on the bottom. I can pair this 5 over here with 5 on the bottom. But here I can see there is no other 5 I can pair this 5 with, and there is no 11 on top that I can pair the 11 with. So I'm only going to use the numbers that I have paired up. So now I can go and write them as 2 multiplied by 2 multiplied by 5. So that means now my HCF would be 2 multiplied by 2 is 4, and 4 multiplied by 5 is 20. So that Right. I hope you pause the video and you try to find the HCF between the number 8 and 32. Let's go ahead and see what we need to do to find the HCF. So again, using our prime numbers, I can see that 2 multiplied by 4 will give me 8. 2 is a prime number, so I go ahead, now I break up the number 4 because 4 is not a prime number. And I can see here that 2 multiplied by 2 is equals to 4, and I can also see that these two numbers are both prime numbers, so that means I'm done and I'm going to go ahead and circle them. That means that 8 as a product of its prime factors is equals to 2 multiplied by 2 multiplied by 2. So remember, when you multiply these numbers, 2 multiplied by 2 multiplied by 2 should give you the number 8. And all these numbers here should be nothing but prime numbers. And then I need to break up the number 32. Right, I ask myself, what number multiplied by my first prime number 2 will give me 32? So now I can see that 2 multiplied by 16 is going to give me 32. 2 is a prime number, so I go ahead and break up the number 16 because 16 is not a prime number. Again, here I can see that 2 multiplied by 8 is equals to 16. 2 is a prime number, so I need to go and break up the number 8 because 8 is not a prime number. Right, now here we have 2 multiplied by 4, which is equals to 8. 2 is a prime number. 4 is not a prime number, so I need to break up the number 4, and here I'm going to have 2 multiplied by 2. So since the last two numbers are both prime numbers, this tells me that I am done. And you can go and circle your prime numbers. And now if I write the number 32 as a product of its prime factors or numbers, it would be 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. Now I have to go and find the HCF. So I go and I pair the numbers up. So this 2 will be paired with this 2 over here. This 2 on top will be paired with this one over here. This 2 over here will be paired with this one over here. Now, as we can see here, there is no number or 2 on top to pair with this one, and there is no other 2 on top to pair with this one. So now I can go and write the numbers that I've paired up. So this will become 2 multiplied by 2 multiplied by 2. So 2 multiplied by 2 gives me 4, and 4 multiplied by 2 gives me 8. That simply tells me the highest common factor between 8 and 32 is the number 8. We have come to the end of the video. I hope you enjoyed the video. Please like the video, share, subscribe, and I'll see you in the next video. Remember, practice makes improvement.